Okay, today's lesson is on comparing linear and exponential functions. The general function notation for linear functions is f of x equals mx plus b. The general function notation of exponential functions is f of x equals a times b to the x. The chart below compares the number of tickets to the amount of dollars. What is the difference of the output values? All right, you notice there were 0 tickets, you had $0. 1 ticket, $10. 2 tickets, $20. 3 tickets, $30, and 4 tickets, $40. So if you subtract 0 from 10, you get 10. But if I subtract 20 from 10, I also get 10 back. 10 from 20, I get 10 back. I subtract 20 from 30, I still get 10. So I notice there's a common difference of 10. Graph the points from the table. Okay, so we had 0, 0. We had 1, 10. We had 2, 20. We had 3, 30. We had 4, 40. So if you look at that, those points line up. We call those collinear points because they line up to form a line. And you can keep that line going out to the graph. There it goes. Is this function linear or exponential? We know it's going to be linear because it forms a straight line. Those points line up in a straight line. And it says write the equation for this function. So we know in general, a linear function has y equals mx plus b. And if you take any 2 points, you can just find the slope. Let's say I take 1, 10 and 2, 20. Then if I get the slope, that's going to be the difference in y divided by the difference in x. But be careful of the way you subtract because you have to stay consistent. So let's say I start with this point. My y-coordinate is 10. So I'm going to say 10 minus 20. But now I have to start with 1 down here and say 1 minus 2. Well, 10 minus 20 is negative 10. And 1 minus 2 is negative 1. And negative 1 divides the negative 10, that's going to be positive 10. The slope is 10, which matches the common difference that we saw in the table. So you could take one of these points and solve for b. Let's say 110. Y in this case is 10. I know my slope is 10. X is 1. And if I simplify this, I can solve for b. I get what the y-intercept is. So 1 times 10 is 10. And if I subtract 10 from itself, I get 0. So I know the y-intercept is 0. So my equation is going to be y equals 10x. Or in function notation, f of x equals 10x. The table below compares the number of events to the number of people in attendance. What is the pattern of the output values? All right, so no events, you had 3 people in attendance. 1 event, 6. 2 events, 12. 3 events, 24. 4 events, 48. So if you look at this, I notice there's a pattern of 2, because 2 times 3 is 6. Then 6 times 2 is 12. So it's a multiple of 2. So that's the pattern. Graph the points from the table. All right, so here's the origin. 0 is 3, it's going to be below 5. It would be somewhere about here. At 1, you get 6, so slightly above 5. 2 is going to be 12. So it's roughly here. And 3 is 24. Roughly here. And 4 is 48. So if you look at this, it kind of forms a curve. And that's a sign of an exponential function. So is this function linear or exponential? It's going to be exponential. Write the equation for this function. Well, we know the exponential function is y equals a times b to the x. And we know from the pattern that this has to be 2. The base is going to be 2 because it multiplies by 2. And we know the initial point was 3. So that's why I'm going to put A for 3. And if you test this out, you'll see it works out. How are the graphs alike? How are they different? The graphs are alike because they have a common difference. We'll say they're both discrete. Both graphs are discrete because they have a pattern. First one had a common difference of 10. The other one has a common multiple of 2. And how are they different? Well, one's linear and one is exponential. All right, this concludes our lesson for today.